This time I'm going to look at the foundation tier specimen paper for CCEA's Double Award Science, and it's the chemistry component and it is Unit 2, so it's the C2 foundation tier paper. So question 1. Gates and other metal structures containing iron are protected from the effects of rust by painting them. State the chemical name for rust. So 2 parts of this. Hydrated is for 1 mark, and then iron 3 oxide is for the 2nd mark. Don't leave out the 3, you might not get your marks. What are the 2 conditions necessary for rusting to occur? Well, water and oxygen, and they will mark you correct if you write moisture, but water of course is better. Explain why painting gates can prevent rusting. You need to be talking about some way of explaining that the paint provides a barrier which prevents the air and or the water reaching the iron. Now, if a bicycle is left outdoors, it can become rusty. For each part of the bicycle listed, choose the protection method which is most suitable from the list below. So if you get from the list below or from the words or whatever, don't go rogue, use those, otherwise you will not get the mark. So you have a choice of plastic coating, galvanizing and oiling. So the bicycle frame is going to be galvanizing, the chain obviously is oiling, and then the handlebars plastic coating. Then the last part of this question, when a bicycle rusts, an oxidation reaction occurs. Explain what is meant by the term oxidation. So it's the gain of oxygen or the loss of hydrogen. Number 2, a student investigated displacement reactions and recorded some observations in the table. So if we have a look at the first one with copper and zinc nitrate, so we've got a colourless solution turned blue and a solid formed. Iron and zinc nitrate, nothing. Silver and iron 2 nitrate, nothing. Zinc and copper 2 nitrate, the blue solution turned colourless and a solid formed. And then the iron and copper 2 nitrate, blue solution turned colourless and a solid formed. So a solid is formed when copper reacts with silver nitrate solution. What colour would you expect the solid to be? So copper is more reactive than silver, so it's going to push the silver out, it's going to displace it, so it will be a silver or grey colour. Why did the blue solution turn colourless when zinc powder reacted with copper 2 nitrate? So that is this one here, and all they're looking for in the explanation is that zinc nitrate is colourless. Right. It's looking for it really, why is it colourless? So don't be saying that the zinc is more reactive or anything like that. It's just the fact that zinc nitrate is colourless there. Part C, using the information from the student's investigation, list the metals copper, iron, silver and zinc in order of reactivity from the most reactive to the least reactive. And you'll see here they've got most and least reactive in this table. So it's a matter of going back and looking at what has happened. So we can see that the zinc has displaced copper here, and then iron has not displaced zinc, so zinc has to be top. Iron has displaced copper but not zinc, so it has to be second. And copper has displaced silver, and nothing. Silver hasn't displaced anything. So our order then, zinc, iron, copper and silver. And the way it was marked, if you got all 4 right, you got 2 marks. 2 or 3, you got 1 mark. And I'm afraid if you only got 1 or none right, you got 0. So then, using these observations and your knowledge, suggest which combination of metal and metal nitrate would give the most exothermic reaction. So the most exothermic is the one which is going to give out the most heat. So it would be the biggest difference in reactivities. So you want the zinc metal and the silver nitrate. If you went for zinc nitrate and silver, silver would be able to displace the zinc from that solution. Okay. Number 3, explain what's meant by the term electrolysis. So it's the decomposition of ionic compounds, that's your first mark, using electricity, and that's for the 2nd mark. Okay, so first mark for decomposition of ionic compounds, 2nd mark for using electricity. Now, state the names of the positive and negative electrodes. So the positive electrode is the anode and the negative electrode is the cathode. And the little way that I get my students to remember that is panic. So positive anode, negative is cathode. When it comes to electrolysis, don't panic. Ionic compounds such as lithium chloride conduct electricity when molten or dissolved in water. Explain why lithium chloride does not conduct when solid, but does conduct when molten or dissolved. So 3 marks for this. One is going to be about the solid. So in a solid, the ions are in fixed positions. And then when they're molten, the ions are free to move and carry a charge. So some way of qualifying that when it's solid, the ions can't move, and when it's molten or in solution, the ions can, and that the charge is moving. So 3 marks there. Electrodes are made from graphite. Give one reason why this is suitable for this use. So any of these, good conductor, it's inert or unreactive, and it has a high melting point. Now you see here, not cheap. The mark scheme specifically said not to include that. So think of it like a chemical property which is suitable. Then describe the product at the positive electrode. So the positive electrode is going to be the chloride ion, it's lithium chloride. So it's going to be either green yellow or yellow green, and you know CCEA are very, very specific about the colour changes, so make sure you're using exactly those forms, and gas. 1 mark for each. And then name the product at the negative electrode, so that's going to be lithium. Give one reason why this electrolysis is carried out in a fume cupboard. Well, chlorine gas is toxic, so if you said something about the toxic product or any way of explaining it really. So now we've got this diagram here, that's the first thing you notice, but make sure if you're faced with a diagram, you read all of the text around it. So aluminium metal is extracted from pure molten aluminium oxide by electrolysis using the cell shown below. Describe the production of aluminium metal from pure aluminium oxide in an electrolytic cell. So you see here with the anode, the cathode, the aluminium oxide and molten cryolite, and then a steel tank. So your answer should include the following information. And it's always good when they give you a bit of sort of scaffolding for a question like this. So we can see here at the bottom of the question it's worth 6 marks. So let's see what they're asking for. A reason for using electrolysis is the extraction method. Probably going to be 1 mark there. The name of the ore from which it's been obtained, I would say it's probably another mark. Why the anodes must be replaced from time to time. So you'd be looking at maybe 2 marks there, and then a fully balanced equation for the production of aluminium and oxygen from aluminium oxide. So balanced equations tend to be sort of 2 to 3 marks. So I'll give you an idea of where they're coming from. So following that, the first one, a reason for using electrolysis, is because aluminium is very reactive, so reduction with carbon won't work, so electrolysis must be used. The second one, the name of the ore from which it's been obtained, is bauxite. And the third, why the anodes must be replaced from time to time, is because oxygen is produced at them, and at high temperatures it reacts and then burns them away. So I'd say if you're wanting to break down the marks there, I would imagine 1 mark for the oxygen is produced at it, and the 2nd mark for they burn away. And then we have the balanced equation, and you see here we've got aluminium oxide, which is Al2O3, and then we have aluminium and oxygen being produced, and the molar amounts then 2 Al2O3, 4 Al and 3 O2. Typically the way these questions are marked is like if you have, so let's see, each of these would be 1 indicative mark. So I'm going to have 1 for each side here and 1 for balancing. So 1, 2, 3, 4, 5, 6, 7 as a total. So I'm going to assume here that if you had 6 to 7 indicative points, that would give you 6 marks. If you had 4 to 5, that would put you in the 4 mark bracket, and if you had 2 or 3 marks, that would put you in the 2 mark bracket. So 2 to 3 would be 3, and then 1 would be, 2 to 3 wouldn't be 3, would it? It would be 2, and then 1 would just be 0. Moving on then to the next one. Organic chemistry is the study of Carbon compounds. For ease of classification, organic compounds are split into different homologous series. So give two features which are common to members of a homologous series. So any two of these, okay, so they differ, each one differs by a CH2 group. You could say they have the same general formula, or you could say they have similar chemical properties and a graduation in physical properties, or a gradation in physical properties. Crude oil is the world's main source of hydrocarbons. It's a mixture of many different hydrocarbons. Before they can be used, they must be separated by a process called fractional distillation. That'll probably come up later. What is meant by the term hydrocarbon? So it's a molecule containing hydrogen and carbon only. So the first mark is for the hydrogen and carbon, and the second mark is only. When it said in the mark scheme, the second mark is dependent on the first, so you would only get that second mark if you got the first part correct. What physical property of the hydrocarbons allows them to be separated by fractional distillation? Well, it's the fact that they have different boiling points. And then further processing of the separated hydrocarbons is needed to provide the actual molecules needed by the petrochemical industry. Butane and ethene are obtained by the cracking of hexane, so butane and ethene, and then of hexane, which is C6H14. Suggest the homologous series to which hexane belongs. Well, it ends in ane, so it's an alkane. And then write a balanced symbol equation to represent the cracking of hexane, which again it tells you C6H14 to form butane and ethane. So what this question is asking you is, can you write the formula of butane and ethane? So you're not getting anything there for the C6H14 because it's given in the question. So you see that there are 2 marks, and those are for writing the correct formula for butane. So meth, eth, prop-but is 4 carbons, so C4H10, and it's an alkane, so it's CnH2n plus 2, so C4H10. And then ethene, so meth, eth, 2 carbons, so C2, and then alkane's general formula CnH2n. So C2H4, 1 mark for each of those. And I would hope, to be honest, you would know the formula for butane and ethene by the time you're going into the exam. It's a good idea to have learned the formulas for methane, ethane, propane, butane, and then ethene, so that you know those before you enter the exam. So a student investigated the combustion of butane. The vapours produced were first cooled and passed over anhydrous copper sulfate and then passed through lime water. The following observations were made. So we've got the reagent and the observation in a table. So lime water went from colourless to milky, and anhydrous copper 2 sulfate went from white to blue. So from the table, identify the 2 products of combustion. So lime water going cloudy to milky, we know that that's carbon dioxide. And then the anhydrous copper sulfate going from white to blue as a test for water. And that might come up elsewhere, but typically for the products of combustion, you're always going to look for carbon dioxide and water, unless it's incomplete combustion, in which case it would be carbon monoxide and water. Now we have chloroethene, which has a common name vinyl chloride, is a monomer with the structure shown below. And here it is. You'll see that there's a carbon-carbon double bond. There are 3 hydrogens, and one of the hydrogens has been substituted for a chlorine, which makes it chloroethane and not just ethane. So a large number of these molecules can join together in a long chain to make a widely used polymer, PVC. So PVC is polyvinyl chloride, sometimes known as vinyl, for any record fans out there. So what is this process known as? Well, it's addition polymerization. 2 marks. So if you just said it was polymerization, you get 1, but because you're breaking the double bond, it's addition, so that is your second mark. The main constituent of vinegar is ethanoic acid. An investigation into the reactions of ethanoic acid in salt formation was recorded in a lab book as follows. So solid A was added to the ethanoic acid in a test tube. I saw bubbles and put a lighted splint into the test tube and heard a squeaky pop. Identify the gas formed. Well, it's a gift, isn't it? It's hydrogen. Squeaky pop, always hydrogen. And then classify solid A. Well, something which is added to an acid and produces a hydrogen as the product must be a metal. Remember, an acid plus metal gives you salt plus hydrogen. Test 2, I added solid B to the ethanoic acid in the test tube and saw bubbles. When I put a lighted splint into the test tube, the bubbles made it go out. Well, that's testing your knowledge of the uses of different gases. So of course the gas is carbon dioxide, also used as in fire extinguishers and so on. So classify solid B. Well, if it's making carbon dioxide, then it has to be a carbonate, so a metal carbonate. And solid C was added to ethanoic acid, no bubbles were seen. So classify solid C. Well, it could be a hydroxide, it could be a metal oxide, it could be a base, or it could be an unreactive metal. So you have plenty of choice there. So it's really asking, do you know something which can react with an acid which will not produce bubbles? Number 5, copper sulfate crystals are described as containing water of crystallization. What do you understand by the term water of crystallization? And there are 2 marks for this. So it's water which is chemically combined or bonded to the crystalline structure. So it's just a matter of learning that definition. Now a student weighs out 2.5 grams of hydrated copper 2 sulfate, which has been on a shelf in the chemistry store. The label on the container states that the salt is CuSO4.5H2O, but as the lid has not been replaced properly, it was decided to check how much water of crystallization is present. So calculate the relative formula mass, first of all, of water, H2O, and it gives you the relative atomic masses of hydrogen is 1 and oxygen is 16. So 2 hydrogens is 2 times 1, which is 2. 1 oxygen is 16. So 2 plus 16 is 18. So your formula mass for water is 18. Next, calculate the relative formula mass of the hydrated copper 2 sulfate, CuSO4.5H2O. So what I've done here, again, it gives you the masses. Copper 64, sulfur 32, oxygen 16 and hydrogen is 1. So working out the CuSO4 part, we've got 1 copper, which is 64, 1 sulfur, which is 32, and 4 oxygens, so 4 16s, which is 64. We add all that together, we get 160. And you've just worked out the formula mass for water up here. And we know from this there are 5 molecules of water per copper sulfate molecule. So 5 H2Os is 5 18s, which is 90. So 90 plus 160 is 250. So 90 for the water and 160 for the copper sulfate. So the hydrated copper sulfate is heated until it is a constant mass, and the mass of anhydrous copper sulfate obtained is recorded as shown below. So we have the mass of the evaporating basin here, 153.8, the evaporating basin and the copper 2 sulfate, 156.3, and that's the hydrated copper sulfate. So the mass of the hydrated copper sulfate then is 2.5. So that is just this one. This one. Take away the top one. Okay, so then the mass of the evaporating basin and the anhydrous copper sulfate is 155.19. So to find the mass then of the anhydrous copper sulfate, it is this number, take away the top one, which gives us 1.39 grams. So how can the student ensure that the dish has reached a constant mass? They can heat the dish repeatedly until there's no change in mass. So you heat it and let it cool down and find the mass, and you heat it again and keep going until there's no further change in the mass. So I've already done this. Complete the table by calculating the mass of the anhydrous copper 2 sulfate, and I did that just so I didn't have to flick up and down in the question. So then what is the mass of the water evaporated? So you can see there it is 1.11 grams, and that is the difference here between the 2.5 and the 1.39, the mass of the hydrated and the anhydrous copper sulfates. And ECF just means error carried forward. So if you've made a mistake in the first part of the question, filling in the table, they'll take that into account in that part. So then it says the same experiment was conducted with a 2.5 gram sample of hydrated copper sulfate from an unopened container. Remember the other one it said had been left open. The lid had not been replaced properly. Okay. So the difference is that this second one has had a watertight lid, and it says the mass of water which was evaporated was calculated to be 0.9 grams. So instead of 1.1 here, it's 0.9. And which one contained more water of crystallization? So the one from the opened container, it had 1.1 grams. And the final question is number 6. Hydrogen peroxide decomposes slowly in sunlight to produce water and oxygen. Write a balanced chemical equation for this reaction. So hydrogen peroxide is H2O2, and it says it gives you water and oxygen, so H2O and O2. Balancing that, we need 2 in front of the H2O2 and 2 in front of water. Now, 3 marks for this, so I would guess it's 1 mark for the left hand side, 1 for the right hand side, and then 1 for the balancing. It says this reaction is very slow, can be speeded up by adding a black powder MnO2, which is manganese 4 oxide, which acts as a catalyst. Explain what is meant by the term catalyst. So a catalyst increases the rate of reaction without being used up itself, and you see 2 halves of that for the 2 marks. So increasing rate is 1, and without being used up itself is the second mark. Name a piece of equipment you would use to measure the volume of oxygen produced in the laboratory. Gas syringe. You could have said something like an inverted measuring cylinder, it was filled with water, something like that, but gas syringe is probably the most obvious. So then oxygen is very reactive and forms oxides with metals and non-metals. Complete the table below with information about 2 oxides. So we've got the name, the formula, and then acidic or basic, and you have to fill in both the formula and whether it's acidic or basic. So we know that non-metals are going to give us acidic oxides. So carbon dioxide will be acidic, and magnesium oxide, metal oxides are going to be basic. And then the formula, carbon dioxide is CO2 and magnesium oxide is MgO. And if you're not sure about that, you just look up your periodic table. Magnesium is group 2, oxygen is group 2, and you can work out the formula by using the valencies method, which gives you Mg2O2. Just like in maths, you can cancel the numbers if they're the same, so it's Mg. Finally, we've got a nice little graph. So the reaction of calcium carbonate or marble chips with hydrochloric acid is often used in the laboratory to produce carbon dioxide gas. The curve shows how the volume of carbon dioxide produced by reacting excess powdered marble chips with hydrochloric acid varied with time. So you see time along the x-axis and the volume produced is on the y-axis. So it says the experiment, there's our first line there. Okay, so it goes up quite steeply and then flattens off. So the experiment was repeated. The only change was to use marble chips instead of powdered marble. On the same grid, sketch the curve you would expect for this reaction. So in this case, you need to be going more slowly. So starting at the same point, you see I've written that there, starts at the same point, so at the origin, and goes up slowly, but flattens at the same level. So you're getting the same amount of gas produced because it's the same volume of hydrochloric acid each time. Okay, so that's the end of the specimen paper for Unit 2 for foundation.